still solving quadratic functions using the quadratic formula. What did I say was so special about the quadratic formula? You can use it anytime. You can use it for any quadratic function. Can we use solving by factoring anytime? Do you think you can use solving by factoring anytime for any old quadratic function? No, just like we learned when we were working with trinomials and binomials that were not in equations. Sometimes we would find out we had some that were not factorable. That's what can happen when they're in an equation. They can be not factorable, but that does not mean they don't have a solution. Not factorable does not equate with no solution. Not factorable means just can't factor it. So we can't use the solving by factoring for just any old quadratic function. How about the solving by the square root method? Can we use that for just any old quadratic function? Solving by using the square root, finding the square root of both sides. Can we use that for just any old one? No. So the only one that we can really rely on that says, you know what, if you can't remember any other method, you need to remember this method. So that's why I said get this crazy formula memorized. So, who knows? Okay, go ahead right now without even saying it out loud right now. With everybody up in the white space on their papers right up here, would you write the quadratic formula? Write it down. What is the quadratic formula? No using yesterday's notes. I know that I always tell you oftentimes to have the previous day's notes up, but I kind of want you to try and do this from memory right now. What is the quadratic formula? Okay, should we say it together? X equals negative b
plus
or minus
square root of b square
square. Oh, there should be a square in there. Square root of b squared minus it can either be plus a negative 4 or minus 4ac. What is that b squared plus a negative 4ac or b squared minus a 4ac? What's that called again? The discriminant. Okay, all that's upstairs in a fraction, correct? What's downstairs? 2a. Yeah, that's the easy part to remember, right? Okay, so hopefully you have memorized it, or you're really close to, you do not need any help. You don't need a cheat sheet, you can write it down, okay? And again, this could also read plus a negative 4ac. Okay, so sometimes, which actually ended up happening in our homework for today twice, sometimes you will need to put the equation in standard form first. Now, this is one of those times that I'm going to say to you, it really does not matter whether A is positive or negative, because we're just going to substitute it into the quadratic formula. We will not necessarily create more work for ourselves. But I like to stay in the habit of just always letting A be positive. For whatever crazy reason, I don't know. It's just, a habit I've gotten into. Let A be positive, because then if I can use one of the other methods to solve it, it's ready and friendlier for it. So if I wanted to keep A positive in this one, what would I do to get it in standard form?
Negative x on both sides.
We're going to add negative x to both sides? Okay.
Both sides by negative x.
So if I did this, class, what's negative x plus negative x? What's a negative 1x plus another negative 1x? Negative 2x. So can I add a negative x to get that? Have I accomplished anything by doing that? Just add positive x. Yeah, we don't want to add a negative x. We want to add its opposite, which is a positive x. And so we're going to add x to both sides. And we're going to have negative 2 plus x squared plus x equals 0. So now we have it set equal to 0, but is that other side really still yet in standard form? It really isn't, is it? So what would standard form look like?
X squared plus x minus b.
or plus and negative 2, either way. It could be minus 2 or plus and negative 2. Okay, now we can go to deciding what is our A, our B, and our C. We cannot do A, B, and C until, first of all, the setting go to 0. And putting it in standard form helps us make sure we identify the A, B, and C more accurately, because then you just go from left to right. Our A is what? 1. Our B is 1. Our C is? Okay, go ahead. Substitute it into the quadratic formula because you know how. The only thing in this step should be the substituting in. And everywhere we substitute, we use parentheses. Okay, and this is why, this is one of those times that using the plus and negative for is so much more useful, because one of our variables that we subbed in for is negative. If we want to make sure that we're not making a mistake here, this is where you will typically make your mistake, or at the beginning, the opposite of the B, the negative B. Okay, in this next step, we're only going to clean up some things. What's the opposite of 1? Negative 1. Radical sign could get probably a little bit shorter this time, but what's 1 squared? 1. Negative 4 times 1 times negative 2. 8. I don't need that long of a radical sign. Okay, I need a fairly long fraction bar though, and downstairs I have 2. Okay. So what's our discriminant? 9. The number underneath the radical sign is our discriminant. That discriminant tells us how many solutions should there be? 2. Why is it 2? Because it's a positive discriminant, so we should end up with 2 solutions for this. So we have x equals negative 1 plus or minus what? 3. The square root of 9 is 3. That plus or minus in front of it takes care of the positive 3 and the negative 3. So we really have x equals negative 1 plus 3 over 2, and we have x equals negative 1 minus 3 over 2. What's that one? Negative 1 plus 3 is 2. 2 divided by 2 is 1. There's one of our solutions. Negative 1 minus 3 is negative 4. Negative 4 divided by 2 is negative 2. So we have our 2 solutions that we predicted. There should be because our discriminant was positive. Okay, let's go check it out the graph calculator. So check this out. What'd you find out? Checks out? Okay. I'm just curious, what if we had, for whatever reason, decided to rearrange it the way I have over here? Which, after I get it rearranged this way, in standard form, what would come first? Negative x to the second. What would come next? Minus the x. And what would come last? plus 2. Okay, now I want you to go and I want you to put that. Don't take out the one that's in y sub 1. I want you to put that one into y sub 2. It's just another name for the same quadratic function with a negative a value instead. But big deal. Remember I said when you're doing a quadratic function, it's not as big of a deal. So would you put in negative, not subtract, negative x squared, subtract x plus 2. And when you graph it, what does it do? Just opens down, right? But do they still both cross the x-axis at the same spot? They do, don't they? So this quadratic function only has these two solutions, regardless of how we rearrange the quadratic function. The solutions are the zeros, and they share the same zeros, whichever name we use. So if we use the quadratic formula for this one, a equals negative 1, b equals negative 1, and c equals positive 2, should we get the same solutions? Yeah. Yeah. It's just that we're just our a, b, and c are different, so we're subbing them in, and so when we sub them in, we still should get the same exact solutions. We should still be taking the square root of 9 eventually in our quadratic formula. Okay, let's go to the back side and see what we got back there. Okay, you go ahead and do this one. You get to decide how you want to rearrange it. It's got to be set equal to 0 before you can decide your a, b, and c. And I'm going to go against the grain and do what I don't typically do. Some of those calculators are coming out now. I got some big numbers to work with, huh? See if you agree with me. Don't assume I'm right. Now, the other thing you have to worry about is that you're going to get the same solution. You may not have used the quadratic function the when you graph it, it's like, I'm not giving you a good graph, you don't really see it well. And then the Zoom 6 should take care of it, but it doesn't let me know. Haven't heard any yays or nays for my answer yet. Anybody like my answer? I just checked it out on my graphing calculator, and according to my graphing calculator, I'm right. Okay. Anybody do it the same way I did? Will you move the x4 squared over like I did? Okay, anybody else? Okay. Let me predict for you right now what I think should happen when you did it the other way. So, Tori, will you verify this for me? On your paper, does yours instead right here say -12 and +8?
No, I'm the same thing.
You did it the same way I did. You didn't raise your hand, so I thought you did it the other way. Aurora, can I predict that your paper looks like this then? And this, when you get down to this step right here? Am I right? Does your paper look like that? -12 plus or minus the square root of 0 over +8? So notice what changes. So did we all end up with the same discriminant though? We're all going to end up with the same discriminant. That can change. But in mine and Faith's, and Tori's and Julia's, in ours, we had the 8 being negative and the 12 being positive. But does that make a difference in this one? Because this is 0, right? Plus or minus 0 is non-essential, kind of not worth. Positive divided by a negative, negative divided by a positive. Doesn't matter, we still get -3/2, don't we? Okay, so when you're rearranging them, make sure you're careful to rearrange them correctly. But if you don't do it the same way as your neighbor does, that does not mean that that's why we've got a different answer. It just might mean you didn't rearrange it correctly. Okay? Anybody have any questions? Or we practice some more of the quadratic formula? Okay, then let's get to work on your homework. Remember, you're doing number 3 if what? If you got it wrong on the homework for today. If you got it right, do you have to do it? Okay, do I have your paper to show that you should or shouldn't be doing it? Yes, I do, right? Yes, no.